Good day everyone! We are the reporter of week 4 to 5. So, our topic is all about data structures and algorithm list using Python. So first, let's define what is linked list. A linked list is an ordered collection of values. Linked lists are similar to arrays in the sense that they contain objects in a linear order. However, they differ from arrays in their memory layout. Also, linked list is the most simplest and most common data structures used in programming. Also, linked list is a data structures that is basically a chain of nodes in which each node is connected to each other by means of pointer. So next, overview of linked list. A linked list supports manipulations of items at any point within a linear connection. Items in a list are not necessarily sorted. So here in overview of linked list, we have some example of list. For example, the recipe, which is a list of instruction. The documents, which is list of words. So next, linked list representation. Here in linked list representation, we have head, node, tail, and index. The head is the first item in a list. Node contains data and pointer to next node. Tail is the last item in a list. Index each numeric positions from 0 to length -1. So, yung sinasabing head po dito is ito yun. Ito yung pinakauna. Then, yung sinasabing node is itong mga to. Itong isa, dalawa, tatlo. So, sinasabi dito na yung node is may dalawang parts, which is the data and the pointer. Then, next is the tail. Ito yung po yung dulo. Then, index is the numeric position. So, let's have an example. We have nodes here. 3, 4, 5. Then, null. So, first we have the head here. Then, this is the tail. So, ang tawag dito sa bawat square is node. Ito yung mga node or object. Ito yung last node is the tail. Pinopoint niya is null, which means wala na siyang kasunod, kaya tinawag na tail. And dito naman is walang object, kaya tinawag na object. Then, so, here in nodes, composed of two parts. Ganyan, may dalawa siyang part. Then, the first part is, kunyari itong isa, itong side na isa or dyan. Ito yung tinatawag nating data. Then, the other one is the pointer. Ito yung sinasabi kanina dun sa nauna. Kunyari, we have here the data 7, 6, 9, 3. For example lang po. Then, ito nga yung sinasabi nating pointer. Itong kabila. Na kung saan ang pointer is, ito yung nagtuturo na kasunod sa kanya. Ang hinhold niya is, kunyari ang hinhold niya is yung address ng kabila. So para mas maliwanag, kunyari ma-example tayo, ang address nito is 1,000, then ito 2,000, ito 4,000, 5,000. So, kahit hindi sunod-sunod. So, di ba ito yung pointer? So, ang i-address nito is itong 2,000 doon. Tas, ito naman, ang i-address na itong kabila is itong 4,000. Pag dito. Then, pag dito, ito, ang i-address naman niya yung 5,000. Dito. Then, kunyari, ito na yung last. So, sinabi gang last. So, ang kasunod nyo, null na. So, 0 na, wala na siya. Ganun. So, example natin para malalong. Kunyari, may isang, ano ba to? Subdivision here. May mga bahay. Kalat-kalat siya. So, kunwari, gusto mo hanapin yung crush mo, dito yung bahay nila. Kunyari, si C. Then, diba, pagpasok mo dito yung entrance pa lang. Kunyari, magtatanong ka sa first bahay, which is, pag nagtanong ka, hindi nila alam. So, ang gagawin nito is, ituturo ka niya sa kabilang bahay. Then, dito sa 1, ituturo ka niya. Then, kung hindi pa rin niya alam, then, ituturo niya ulit ikaw sa 2. Ganon. Tas, kung hindi, tas ituturo ka din niya dun sa mismong, yung hinahanap mong bahay ng crush mo, ganon. Parang sunod-sunod lang siya. Ina-address niya yung kabilang, ina-address niya yung isang sa kabila, sa kasunod niya, ganon. Ina-address niya yung sa kabila. Ganon. So, let's proceed to the types of linked list. First, simple linked list. Item navigation is forward only. So, simple linked list is the most common used linked list. And also, here in simple linked list, each node contains two data parts. Which one is the data and the other one is the pointers to each next node. So, ito yung sinasabi ko kanina. This is the head. Also, we have 3 nodes. The first one, the second one, the third one. So, here in simple linked list, we have 3 nodes. Ito yung tatlong nodes. Then, it divided in 2 parts, the data and the next, or should we call pointers. Ito yung data, ito yung 1 yung data. So, tapos, ito ang pointers. So, ang nilalagay dito sa pointers is the address of the next node. So, ang nilalagay dito yung address nitong 2. Tapos, ang nilalagay naman dito sa 2 is yung address ng last. Then, dito sa last, ang nilalagay is null na kasi wala na siyang kasunod. Parang end na siya, kaya tinawag na last or tail. Then, dito naman sa head pointer is, ang nilalagay dito is the first node address, yung address ng 1. So, parang ganun. So, this is the example of single linked list. Single linked list. Here in single linked list, there are, for example, there have 3 nodes. 1, 2, 3. Then each nodes have 2 parts. Let's divide it in 2 parts. First, let's have the data contains of 15, 9, and 12. This is the data, and the other parts is the pointers. And let's have example. The address of the first node is 200. Then the address of second node is 400, and the third node is 600. So this is the pointer. So this is the data. This is the pointer. and this is the address. So now let's proceed. Ang nilalagay po dito sa pointers is pag sinabing single linked list is ito yung link only forward, have one direction lang. So ang nilalagay ditong address is the address of the next node. Ang sabi nga po pag pointers, let's try for example, ang address po ng second node natin is 400. So yun ang ilalagay natin dito, 400. Then dito sa second node, ang ilalagay natin na address is the third, which is 600. Then dito sa third node or last, pag sinabing last is the tail or the end. So wala na siyang kasunod. So ang ilalagay mo either null or 0. Ganun lang po, kaya tinawag dito is the tail. Then we have here the head pointer. Pag sinabing head pointer po, ito yung pointer lang, wala siya yung data. Parang sa node, isang part lang, ito yung sa head. Ang nilalagay po dito sa head is the first address of first node. Itong 200. Ganito po siya. Ganyan po ang single linked list. Parang isang way lang po siya, isang direction pa forward, hindi na kung saan-saan po.
Then next, we have the doubly linked list. Items can be navigated forward and backward. So it means hindi lang po siya yung forward kagaya ng single linked list, pwede ding backward. So like this, ito yung point and forward and may backward siya. So let's have an example po.
So here in doubly linked list, having a 3 parts. One is the data part and the 2 is the pointer to previous node and the pointer to next node. So like this po, doubly linked list. Doubly linked list. So sabi po is ang isang linked list is may 3 parts. Ay, ang isang node may 3 parts. Diba ito po yung node. So divided natin ng 3 parts. So this is the data part, then this is the pointer to the next node po. Pointer to the next node, then this is the pointers to the previous node. So let's have example para mas maliwanag po. Say like for example, we have 3 nodes. 1 2 3. Each node is divided into 3. Like this po. For example, this first node have 15 data, then second node is 9, then the third node is 12, and it have 200 address, and the second node is 400 address, and the third node is 600 address. So we have this, the pointer, head pointer. Yan po, ganito po itsura siya niyan. So this pointer contains the address to the next node. So ito po yung address ng next node. So ito ang ilalagay natin dito, 400. Then ganun din po dito, ang address of the next node is 600. Then dito is still none pa rin po kasi wala naman siyang kasunod. Dulo po siya yung tail. Then dito po sa double is, sabi kanina is forward and backward. So may backward po. Kanya let's start here. Dito po sa may head pointers nito is
still meron pa rin po kasi 200 point forward. Then gagawin po natin yung sinasabing backward kasi double linked list. So ganito po yun. Here we have 600 in the third node, 600 address, 400 in the second node, and 200 for the first node. So sabi po dito is backward. So dito sa first pointer is na lang ilalagay natin kasi walang previous na node. So dito naman po sa second node is ang ilalagay natin is the first address. Ito po kasi meron siya 200. Ganito po. Then dito naman po sa third node is 400. Ganito po ang doubly linked list. It have two link. One is the forward and the other one is the backward. Sabi nga po kanina sa meaning. So ganito po ang itsura niya. And that's all. Thank you.
There are many different types of data structures that can be implemented in computer programming, such as array and linked list. For some reason, it is important to understand the difference of each data structures when it comes to designing, optimizing, and scaling program. So now let's differentiate the array and linked list. So arrays are contiguous data structures and they are composed of fixed size data records stored in adjoining blocks of memory. Arrays are simply like a container that can hold multiple values of the same types. All values in an array have an particular addresses that can be specified by its index. In an array, data is tightly packed, and we know the size of each data record, which allows us to quickly look up an element given its index in an array. So I have here an simple structures of array. So indexing always starts from 0. Therefore, index 0 holds the value 1. Index 1 holds the value 3, and so on and so forth. So now let's go to linked list. Linked lists, however, are made up of data records linked together by pointers. This means that the data records that hold the actual data payload can be stored anywhere in memory. What creates the linear ordering is how each data record points to the next one. So linked list is basically a linear data structures in which the element is not stored in contiguous memory locations, which means that they can be scattered anywhere in the memory but still functions properly. So I have here an simple structures of a linked list. Jaden already discussed it, so let's go to the next one. So now let's go to how do linked lists and the arrays compare performance-wise. So first, element and insertion removal. Inserting and removing elements from a double linked list has time complexity big O of 1, whereas doing the same on an array requires an big O of n copy operation in the worst case. On the linked list, we can simply hook in a new element anywhere we want by adjusting the pointers from one data record to the next. So I have here a video on how to add an element in linked list. So gagawa tayo ng example kung paano bang mag-insert ng new node sa linked list. So meron tayo ngayon ditong dalawang nodes, position 0 with the data 10 and position 1 with the data 20. So syempre, sabi dito, insert a new node in between two nodes. So syempre kailangan natin ng isa pang nodes. Meron siyang data 15. So ngayon, kailangan natin i-identify kung saan ba siyang position ilalagay. So sabi dito, ito position 1. So meaning, dito siya sa gitna ng dalawang to. So, paano nga ba natin i-connect? First, we need to traverse the list till the position 1. And after that, we need to store details of the previous node, which is the position 0, in a temporary node. So, after that, pwede na natin tanggalin yung connection ng dalawang to. So, ngayon, gumawa na tayo ng connection sa bagong nodes na magiging position 1. At yung position 1, i-connect na natin sa previous nodes. At magiging siya ngayong position 2. So, this is the position 0, position 1, and position 2. Ganun lang. Kaya siya tinawag na big O of 1 kasi mas madaling mag-insert ng new node sa linked list kumpara sa array. Meanwhile, on an array, we have to allocate a bigger storage area first and copy around the existing elements, leaving a blank space to inserting the new element into. So let's watch the video on how to insert an element in an array. So ngayon, gagawa naman tayo ng example kung paano ba mag-insert ng new element sa array. So meron tayo ngayong array na may length na 6. So sabi dito, mag-i-insert siya ng new element sa position 4. So ang insert na value is 20. So paano natin gagawin yon? First, kailangan lang natin gumawa ng new array na may length na mas mahaba pa sa original. So magiging array 2 siya. Tapos, ika-copy lang natin yung value 2, 18, 11. Tapos, i-insert na natin sa position 4 yung value na 20. And then, i-copy na lang natin yung 25, 60, and 24. So, ganun lang kadali kung paano mag-insert ng new element sa array. Kaya naman siya big O of n kasi mabagal siyang insert ng element kaysa sa linked list kasi kailangan pa niyang gumawa ng bagong array para makapag-insert ng new element. So, now let's go to element lookup. Similarly, looking up an element given its index is a slow big O of n time operation on a linked list, but as fast as big O of 1 lookup on an array. What does it mean? Looking up an element in linked list is slower than an array because we need to traverse or we need to trace the linked list to find the element. We need to jump from element to element and search the structures starting from the head of the list to find the index we want. That is why it takes big O of n time. But with an array, we can calculate the exact address of an element in memory based on its index and the fixed size of each data record. That is why it takes big O of 1. So next, let's go to memory efficiency. Because the data stored in arrays is tightly packed, they are generally more space efficient than linked lists. Memory consumption is more in linked lists compared to arrays because each node contains pointers and it requires extra memory. This mostly applies to static arrays. However, dynamic arrays typically over-allocate their backing store slightly to speed up element insertion in the average case, thus increasing the memory footprint. So now let's go to the next slide. Linked list complexity. So operation. Insert at the head. Complexity is big O of 1. Insert at the tail. Complexity is big O of 1. Insert at the middle. Complexity is big O of n. Delete at the head. complexity is big O of 1, delete at the tail, complexity is big O of 1, delete at the middle, complexity is big O of 1, search the list, the time complexity is big O of n.
Hello guys, ang topic ko po ngayon ay how do we write a linked list using Python? So, we have two options. Option 1, we could either use the collections.q class from the Python standard library and take advantage of the fact that it's implemented as a double linked list behind the scenes. Pero meron pa tayong isang option kung ayaw natin gamitin yung option 1. Ito ay ang option 2. Option 2. We could define your own linked list type in Python by writing it from scratch using other built-in data types. Pwede kahit ano yung gusto natin ilagay, pero sa scratch gamit ang ibang data types. Python also provides some built-in data types. In particular, dict, list, set, and frozen set, and last the tuple. A linked list is sequence of data elements, nodes, which are connected together via links, pointer. Each data element contains a connection to another data element in form of a pointer. So, laging connected ang nodes sa pointer. Kada nodes ay may dalawang parts. The data and next. Data refers to the value of node, and next linked to next node. Pointer link between nodes. So, ito yung kabuuan ng sample. So, yan. Yan ang kabuuan ng sample linked list. Yung data 1 ay nagsisilbing head ng lahat kasi siya yung nangunguna. Susunod na yan hanggang makaabot sa MSIT. MSIT, yun yung last node o ang pointer. At tail na rin dahil yun yung huli. Parang aso gano'n, yung head, tapos yung ulo niya, tapos yung tail, yung buntot niya. And, so yan, append item. Adds item to the tail of the list. Insert index or item. Insert items at position index, shifting other items to the right by one position if necessary, kung kinakailangan lamang. Replace index or item. Replaces the item at position index with item. Remove index. Removes the item at a position index, shifting other items to the left by one position if necessary, kung kinakailangan ulit.